So just so you know, this meeting is being recorded. Please stay muted to minimize interruptions. This session is shorter. It's only 30 minutes, so it will not feature a Q&A section at the end, but we will be administering a Zoom survey. So if you have any questions, you can ask them there. And of course, all meeting materials will be made available in the CCSQ DNA portal. Just make sure to give us a few days to turn those around. With that said, I'm going to go ahead and stop screen sharing and hand it over to our speaker.
Thanks, Laura. I'm going to share my screen. All right. So hopefully you can see my screen now. My name is Katie. I am on the user services team. So thank you for joining us today for this lunch and learn. I'm going to talk about streaming today, structured streaming. And it's one way that we can move data from one place to another. And what I'm going to talk about today, you don't necessarily have to have a continuous stream of data coming in order for this to benefit you. If you have batches coming in, structured streaming is kind of a way where you can treat a stream like a batch. So this can be used for something where you get data deliveries. If you have deliveries coming into one S3 and maybe it has lots of different files in there, if you maybe if you get lots of different CSVs and you have to put them together into some kind of data product, this can kind of help you do that without the extra steps of including some of the logic that you might have to include of, I have this thing in the source, I have this thing in the destination. So this streaming is able to help you automate some of the things that you might be doing with your data deliveries. So just a note, this notebook and this presentation, most of it is set up. The part that the real meat of it is just one cell with the code in it. But I wanted to sort of help you to see that whole flow of everything where we have data coming in, we're going to stream it and write it to a table, and then we're going to look at it, and then we'll do it again as if you get a second delivery of data. Our learning objectives today, we're going to learn how to use a stream to read in the data. I want to talk a little bit about the benefits of stream versus batch, because those are two different things. But real quick, before I move on, I wanted to, because we're talking about jobs, this is something that you would likely run in a job because you can schedule it and have it run with your data deliveries and things like that. So one of the things that you may have noticed is that you have an option for serverless. So there's something here, and don't select that for either for your notebooks or for your job. And one of the things I wanted to point out is that the jobs have the serverless set. If you start a new job or create a new job, sorry, and you scroll down, you'll see for compute, serverless is the default now whenever you create a job. So if you want to do a job, you need to go in here, select job cluster, and then you can go and edit it because you'll need to select, you'll need to select a job policy. And then that will allow you to select your runtime. You'll see 14, 15, and 16. There's also a note about Scala 2.13. That's not compatible yet with some of the packages you might be using, like Sarfong, or if you're using Sparkly R, I think it's not compatible with that either. There is a COM or a KB somewhere that you can find on that, but just as a note, I'm going to select 16, and then I'm going to click confirm. Oh, but there's something happened. This is something else. I just want to show this to you real quick because this is tripping people up. So if you get an error down here, you may want to go down to advanced, click on Spark, and then go down to environment variables. If you delete this and confirm, you should be good to go. This is probably just something we have to do for now. It's not forever, but I wanted to point this out. It's so you wouldn't be surprised by it or anything like that. And if you make a job, if you run this as a job, for example, There's the note, selecting the compute policy. That's important for it to be able to access your S3 and for you to be able to actually run the job cluster. Note about jobs are lightweight. They're good for production work. You can schedule them. They cost less than the dedicated single-use computes. And your dedicated compute is really good for, a lot of things. Like if you're doing exploratory work, if you're trying to develop some code, work on it in your interactive cluster, then you can kind of clean it up and optimize it for your job and run it, on your schedule. So the things that we're doing today, you can run this as a job. You can schedule it. And I'm going to talk a little bit now about what is streaming and what is batch. Because when you think of streaming, you may think of just stuff coming in all the time. Like some companies have streams of data where it's just literally coming in like 24/7. You might think of IoT, where you have maybe a weather station and you can stream data from it, or you might have water quality monitoring, things like that. But we can use streaming even if we are just getting batch deliveries of things. And structured streaming is where you can kind of treat that stream like a batch. And here I have some of the characteristics of streaming and batch, some of the differences. You can append or overwrite with either one. Your batch jobs, you typically may have a big chunk of data delivered in intervals, maybe once a month, once a quarter, once a week, once a day. It could be anything. You can schedule those. You may manually trigger the job whenever you get your data coming in, or it could be scheduled. You can have many parts of it can be automated. And it may take longer for batch because you have the bigger delivery. Streaming, you're dealing with little tiny bits of data, chunks of data at a time. And because data platforms like Databricks are so powerful, Spark is so powerful, and the distributed computing that can, you can still have this low latency even with a lot of data. What you might not normally think of as small bits of data, but they are for this. And then checkpointing, I'm going to talk about in a minute. And then again, append versus overwrite. If you have, you can do either append or overwrite in streaming or batch. So if you have data coming in and you process it, and you may bring all the data in each time. So whatever new delivery you have in your source, maybe you bring everything through your pipeline. And that's really common, and that's okay. If that's fine for your use case, that's fine. Typically, we are also able to append things and only deal with the new data coming in. So that's another option for getting your data together and cleaned up and transformed. So appending is typically what you want to do when you have big data, when you have a lot of data, and you only need to change the new data maybe, or just add it to what you have already. So the checkpoints is something that helps us with all of this. Instead of having to specify logic for what is new, to discover and define what's new, you set this checkpoint option, and Spark will save the information about what is new and what is not in the checkpoint folder. So as long as that is fine and up to date, then whenever you stream, the things that are not marked as new in the checkpoint are brought in. So I can show you that in a minute. But it's the way of marking what's new, or sorry, marking what's old, marking what has already been processed. That is in the checkpoint folder. I'm sorry if I misspoke. So that it will know what's new. It won't have to process everything each time. It won't have to bring in everything each time. So this works really well if you have new data comes in one folder, and everything, all of your raw files can be there. So let's move on to our setup. For the most of this setup is to create files. So if there's anything that you don't follow in this part, that is okay, because I did put code in here that I'm not really going to talk in depth about, but we're just creating files that have random data in them, and then we're going to read that into a table. So this first part right here where we're setting things up, we're creating files, that is just part of this so that I can kind of demonstrate what is going on. And I apologize, I did not share the link to this. I didn't put it in the shared directory yet, but it will be right as soon as we're done. And then we can share that link out. And of course, it'll be out in the comms that go out. So for this S3 path, this is one that I have access to. So please make sure that you put one that you have access to. It's got S3A at the beginning, and that's because we're going to mount it. So make sure it says S3A instead of just S3. The mount path, we have that here, and please change that to something unique. The jobs directory is just something jobs 1, 2, 3, 4. Everything we're setting up and doing in this notebook is going to be in that folder. So you can clean it up easily after you're done if you decide to run this through with something on your own. JSON files is where we are going to put the files that we create to simulate a data delivery. And then the checkpoint files is where Spark is going to save those special files that it uses to tell you which one of these JSON files is new or not. So the catalog table name is your destination catalog. You don't necessarily have to specify this. This is the default. The schema, you'll want to change that to something you have access to. And then table name, you can change that to whatever you want. I just been calling it temp lunch and learn table. So we mount the path. We're creating these directories. They need to exist before we use them and put things in there. And then for JSON files, you have to tell the stream what the schema looks like. For example, we're going to have ID, plant, a value percent, and then date time. So these are just all randomly created. And I'm just telling it, there's going to be an ID, it's going to be a string. There's going to be a plant, it's going to be a string. So that's all this is telling the stream. And this is something you would have to set up if you were doing this like the first time. To set up your stream, you want to have the source. We're going to have to create the table. It'll be an empty table, but it has to exist for the way that we're doing this here. And then you have to have this schema. And I'm generating the data programmatically, and I'm using a lot of functions so that it makes it easy. If you want to play around with this after you're done, maybe you can, or after this presentation, you can generate records and then go in your UFM and make changes to see how does this behave. You can see if you delete all the checkpoints, because sometimes you may have to clear your checkpoint folder if something becomes off on the stream. So if it's trying to detect something in one place, but it's not synced up properly, this is not something you will run into as much with this, like running a job. But if you're able to do pipelines in the future on this platform, that is something that you would need to be aware of, is how do the checkpoints matter in this particular way of bringing in the data. So this is just to generate a record, and then I have a function that will do it 10 times to return a list of records, and then I'm writing those to a file. So I have a JSON file that has 10 records in it, and I'm going to loop through those to read them in. And this is just using a buffer, and I'm using dbutils fs.put instead of creating these files in temp and then copying them over. I'm almost like directly putting them in S3 with this. And then this is the part that we really care about. So that stuff before, that was some setup, and that is preparing for setup. And then this right here is what the code looks like to stream those records to your table. And you can stream to another S3. It doesn't have to go to a table, but pretty frequently around here, we want stuff to be in a table so we can query it. And I've broken this up. This does not have to be broken up into these 3 steps here. This part, it will return a data frame, and you can look at it. if you run this kind of one step at a time, if you broke this up. Read stream, that's where you specify the schema, and then you can tell it, I have a JSON format that I'm reading in. Here's this file path. And that's actually just a whole directory. So if you have a whole directory where you're getting things coming in on a regular basis, this file path is where you can put all of the files in there and it will know what's new and what's not because of checkpoint location. That's the option that you specify here. And this is actually a required option, and it will let you, and then you tell it where you want it to go. So you can put it in a place where you have access to those files so that you can, you could look at it if you want to, but it's more like if you need to clear it or check on something that is a little wonky, but most of the time you won't need to look at that. This trigger is important because if you don't include some kind of trigger, the default is for it to just kind of go forever. So if you don't tell it a trigger of some kind where, oh, I want you to go for 5 seconds and then stop, or I want you to go for 5 minutes and then stop. This is whatever is available right now. So whenever we read this, what we're doing is we're creating those files in the S3. We'll have 100 records, and those will be available now. And we are going to run the stream, and it will get all that stuff. And then we're going to do it again to maybe simulate a second data delivery. Maybe that's the next day, and you get some more files, 100 more files. Then we're going to run this again. And what's available now is all 200 files, or sorry, 200 records. And that checkpoint will know that the first 100 we already read in yesterday, and then this new delivery, it needs to read in today. And you won't notice any difference in time really because we're dealing with such small amounts of data in this example. But whenever you get to very big, large amounts of data, you do see a big difference. And whenever it's reading in just little bits at a time versus everything at a time. So this write stream, we're going to tell it I want a delta table because that's a really nice table format that we can do a lot with. It has the history and a lot of lineage options and things like that. We're going to tell it we want it to append. And so that we open and then also close the stream, we're telling it a specific trigger because we don't want it to be open all the time. So query.toTable, I have this separate because the toTable, there's also a .start, and those two functions will tell it to execute this code that we have here. So this kind of like the lazy execution that you may already be familiar with. It has all this set up, but then we get to the part where it executes at toTable, and then it's going to go to the table that we specify, which has to exist. And then this is just a part of our notebook for this example. You would not put this in here because we just need to slow it down so that the code doesn't go ahead of when the stream goes, because the stream will open and it will continue to run the code because it will think this cell is done, and then it will keep going before the data are actually in the table. And then you wouldn't see that the table has data in it. So that's only in there just for this example. You wouldn't typically put that in. The create table is the next thing that we have here. We're making sure that the destination exists. So whenever the stream tries to write it somewhere, it will have somewhere to go. So next, we're going to actually put this all together. So the part before, we set up functions that we can now use to kind of play around with the different things to see how does this all behave? Where do I see, things happening here and there? So I'm writing, this is actually creating 10 files. So that's, if you count these, there's 10 wrote X bytes lines here because it's writing 10 files. And now we see if we do a listing of the S3, that there are 10 files here. I have this number 1 so that we can create as many as we want. So batch _1 underscore, and then it gives it some numbers afterwards, because you can add more or less if you want to play around with it. So we're going to stream the files from the S3 table. So this is the part where you would probably actually have a notebook with this in it, because the rest of this is just setting up, and then we run this part, and then we look at what we got. So this part is very quick. It would be much faster if I didn't have the thing to tell it to wait. But then we can actually view the table after the data get read in to the destination. We can say, okay, select whatever from that table. I'm selecting the count just to see, okay, I got all the 100 records that I was expecting, 10 files with 10 records each, 100 count. And then this is what it looks like if you select star. So we have our various cactus succulent names, and then we have some kind of percentage, and the times. It does it so quickly that you don't see a whole lot of difference in the times, but there are some. You can see that it's updating with each now time. And then we're going to create some more files. Let's pretend like we have a second day. The next day we get more files in and we want to read them, and we want to trigger our stream to update our table with some more stuff. So then we can display the folder, the single folder that we have JSON files in. There's this batch 1. These are the ones from before. And then now we have 10 new ones called batch _2. And then what it's doing now is it's going to use those checkpoints to only read in batch 2, because it already read in batch 1, and it knows that because checkpoint. Stream JSON files, we're using the same code. So this is as if we were gonna, let's say we have a job that has that one cell and we run it again today, and we ran it yesterday. We're gonna view how many records are in that table. Okay, I see 200. And then we can look at the select star, so we see the actual contents. There's 200 rows, and we can just keep scrolling and see all the data that were generated from our random thing. And then the last part, I have code in here, so you can delete that jobs directory. It's just called jobs 1, 2, 3, 4 up above, and that'll just clean up everything. Those JSON files and the checkpoints, they'll all be gone. So this will delete that free if you uncomment it. And then unmount the mount path to clear that up. And then if you want to drop that table so you don't clutter up your catalog, because the more excuse me, the more things that we have in the catalog, the slower that it is to load. So if we have a lot of extra little things that we don't need, then it can kind of slow things down. And in conclusion, Databricks offers some automation options for working with data input. We have the read stream, the write stream. You don't have to only read in JSON files. You can read in CSVs and other data types with this, so that you can, there's a lot of flexibility in here. There's a lot of other options that I didn't talk about, but these are kind of the basic ones that you might be interested in. So you don't have to specify a lot of logic related to what you have already read and what comes next in your data. And then I have some additional resources, links to different documentation. So I hope you found that helpful, and I thank you for joining. I'm going to give it back to Laura so that she can maybe if we do the survey for this one, and I'll check the chat if there's
Great,
anything.
thank you, Katie. Awesome. So I'm going to go ahead and administer this survey. I know we didn't have enough time for a Q&A section, but if you do have any questions for Katie, or you have any content that you want to see presented on, or even just any question related to the SaaS transition or Databricks, feel free to give us your feedback there in that survey. We do review them and use that feedback to continue improving our sessions. Dan did put the link for the notebook in the chat, so you can access it there. Also, if you're interested in seeing any previous recordings or notebooks for any other session that you've previously attended, you can go to Portal and visit the events, and then just find the session that you are looking for. We do have training sessions almost every week, and the next one will be sent out today. So keep an eye out for that. But with that said, thank you all for attending. Once you submit the survey, you are more than welcome to drop. Thank you all.